go. Planet Measure 8.
All right, back at it. I got the same shirt on. It's not day 2. I'm just keeping this thing rolling. Trying to keep it live with some gorillas. Okay. All right, let's get into this, folks. Okay, so you can see what I have up here are the learning goals. And I didn't talk about these all in my first lecture, but now I'm going to bring this to your attention. This is it right here, folks. This is the list of stuff I want you to know. I got one of these for each chapter. This is your study guide. And occasionally I'm going to go through this and see what we've done and see what we haven't done. Okay? So what did we talk about in the last lecture? So distinguish a substance as an element, molecule, compound, and or mixture. Yep, we definitely talked about that. Okay? So let's see. Can I highlight that? Yes, I can. And I'm also going to point you out to the back side of this page. Then this is on the canvas, all right? If I go all the way down here on this next side, if I were to take a test on this subject today, I would feel. And now look at this. Here's that learning goal number 1 that I just highlighted above. Well, how do you feel? Which category are you in? I would encourage you to have this document out and check these boxes right as you go. Maybe that first lecture, no way you're ready to take a test on that one learning goal because you just watched the first lecture, of course. So then maybe you get some more practice, you're feeling good, and after you've had enough practice, then you move on to that category. Great, let's do this thing, okay? So keep track of these learning goals as we're going. Let's go back up to the top here. So identify a process as a chemical change or a physical change. Yeah, 100%. We did that in the first lecture, okay? Calculate the density of a substance given its mass and volume. So we didn't quite do any calculations with this yet. I showed you how to use the formula, okay? But we're going to get into some more examples of this. So I'm not going to check this one off yet. We did kind of talk about it a little bit, but after we've had some examples, maybe we can revisit this, okay? So identify the correct phase transition a substance goes through given its respective phases. Yeah, we definitely talked about that. Okay. And then now the rest of these, as you can see, these probably don't look very familiar. That's because I'm going to talk about them right now in this lecture. Okay. So we'll come back to this and see how we're doing. All right. So here we go. I've got now my lecture slides that we're going to continue on. Let's do it. Okay. And if the air horn gets annoying, I don't care because I love it. All right, so section 1.8 out of your book, SI units. Okay, the fundamental SI units. That stands for System International, and so this is used all over the world. And contrast to most of the stuff the United States does, right? We're going to use pounds and inches and all that junk. We have this organized way. We have a set of units that the entire scientific community across the world uses so that we don't have to be like, oh, you guys use pounds and you guys use this and you guys use that. If you're a scientist, we all use the same units, all right? Mass, the kilogram is preferred. The kilogram is considered SI, okay? Although in this class, we will use grams quite a bit because in chemistry, you rarely ever have like a full kilogram of something. A kilogram is about 2.2 pounds, so that's quite a bit, okay? So we'll see grams quite a bit, and we're also going to talk on the next slide how we convert from the kilogram to the gram. Okay, length, the meter is preferred, okay? But we note that centimeters, kilometers, millimeters, all of that will be a part of this base meter. Okay, just like a gram is part of the base unit kilogram, or SI unit, really. Okay, so time, seconds, right? Don't need to spend too much time there. Pun intended. So volume, this is a tricky one because a cubic meter is considered the SI unit, but a cubic meter is actually kind of gargantuan. It's kind of a big volume for chemistry. So we will typically use the cubic centimeter, which we remembered from the last lecture that's the same as the milliliter. And we'll talk about how to interconvert from cubic meter to cubic centimeter. Okay. Amount of substance, the mole. We're going to spend a whole bunch of time talking about what the mole is. So stay tuned. So SI unit of force is the Newton. Okay. We really won't do much of that in this class. That'll be more relevant to your physics class. We will use energy units quite a bit, and that's the joule, J for joules. Okay. Temperature will almost exclusively use the Kelvin scale, although you should be familiar with Celsius and Fahrenheit and how to interconvert between these three. And pressure, our SI unit, is the Pascal. Okay, and we're going to get into that in a lot more detail in due time. Okay, so moving right along. So here we have the commonly used prefixes for SI units. Okay, there's a whole bunch of them on here. The ones that I have highlighted on this list and that I'm checking through here are the ones I want you to know for this class. Okay, all of the others, you know, you can memorize them if you want, but you don't have to. All right. But these yellow ones are the ones I want you to know for the class. Okay. So for example, if we look, so this kind of line right here, I'll draw a line. Let's see if I can do that right through here. And really what this line is referring to is, I'll call it the 1 line. Because now if you notice, look, 10 raised to the power 1 is 10. Okay. 10 raised to the power 2 is 100. And then, as you might guess, 1,000, a million, a billion. So then now if we keep going down here, okay, 110, this line is 1. Then 10 to the minus 1, that's 0.1, so you can see it right there. 10 to the minus 2, 0.01, and so on and so forth, right? Okay, so we're going to get practice on how to use these. But I want you to recognize here, the giga, the mega, and the kilo, those are big. When you have a kilogram, you have 1,000 grams. So that's a lot. If you have a gigagram, you have a billion grams. You have 1 times 10 to the 9th power grams. So that's humongous. So these are the large quantities. These are the small quantities. Okay. So deci is 1/10. Centi is 1/100th, right? 1 over 100. Milli is 1 over 1,000. Micro is 1 over 1,000,000. Nano is 1 over 1,000,000,000. And pico is 1 over 1,000,000,000,000. Okay, so be very comfortable with this kind of conversions. We're going to get lots and lots of practice. But if there's any area of the course that you're nervous about so far, and if this is one of those areas where you're nervous, practice makes perfect, right? So I'm more than happy to help you practice through interconverting here. Okay, and a couple more slides, and then we're going to have an opportunity to practice. Okay, so here are SI units, and then of course their US customary unit equivalents. I don't expect you to have any of this memorized. You don't have to memorize any of this stuff. These highlighted things you do need to commit to memory. These you don't. I'll always give you conversions, all right? So for example, I think I said earlier 1 kilogram is about 2.2 pounds, okay? And you can see all these other conversions, right? And we're gonna learn how to use these, okay? I don't expect you to memorize these at all. But you will want to be able to look them up when you're doing your homework problems. And have them, you know, handy where you can find them, okay? So let's talk about volume. Okay, so here I have a box, and as it turns out, this box is 1 cubic meter. So it's 1 meter by 1 meter by 1 meter, which you can see that's right there. And I'm going to use this volume example to show you how we do math with units, because doing math on the number is important, but doing math on the unit is also important, okay? So here we have 3 meters, 1 meter by 1 meter by 1 meter. That makes a cube. Literally, it makes a cubic meter. Okay, so now check it out. I'm going to count these boxes here for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of these boxes, so I'm going to draw like this arrow right here. So that's 1 meter, which actually equals 10 decimeters. And if I back up for a second, look, deci was 0.1. So to get a full meter, I need 10 of these. 10 times 0.1 equals 1. Okay? So now you can see that 1 meter is the same as 10 decimeters. That meter is the same as 10 decimeters. And that meter is the same as 10 decimeters. Sorry, this got cut off a little bit, so that's 10 decimeters. And so now look, when I do this math, 10 cubed is 1,000, okay? But a decimeter cubed is a cubic decimeter. So 1,000 cubic decimeters is the same as 1 cubic meter. All right? And so now we can't draw enough of these to get to a cubic centimeter, but hopefully you can see where this is going. And also, by the way, you notice here that when I have 1 cubic decimeter, that's the same as a liter. Okay? That's kind of cool. So 1 liter is 1 cubic decimeter. All right? So, but now, if we back up 1 second here, so we notice now that 1 centimeter is 1/100th. So it would take 100 centimeters to make 1 meter, right? 100 centimeters and 1 meter. And so here we can see that, and that, and that, right? 1 meter is 10 decimeters, which is 100 centimeters. And if I do 100 by 100 by 100 centimeters, that's 100 to the power 3. Plug that in your calculator. 100 to the power 3 is 1 million. That is 1 times 10 to the 6th power is the same as 1 million. Or if you recall, here another way I can write 100 is 1 times 10 to the 2. And if I cube that, right, 2 times 3 is 6. 1 times 10 to the 6th, okay, to give me 1 million. And then a centimeter cubed is a cubic centimeter. And hopefully you remember that a cubic centimeter is the same as a milliliter. So 1 cubic meter equals 1, So 1 cubic meter equals 1 times 10 to the 6th milliliters. So there's 1 million milliliters in 1 cubic meter. Okay? Great. So I think I can move on from there. But the important thing to note here, I'll write down, if you cube the number, you cube the unit. So whatever arithmetic we do to the number, we do the same arithmetic to the unit. Okay?